Hello everyone, welcome back to my channel. It's me Abhay. So today we are going to be starting the next topic of vectors, which is vector multiplication. And in this chapter, we are going to be dealing with the two most important topics, which is dot product and cross product. So without wasting any further time, let us get into this video. So what and all are we going to learn? We are going to learn what is the difference between vector multiplication and scalar multiplication. You will learn what is something called as dot product. You'll also learn about something called as cross product. You'll also learn application of dot product, which is projection of a vector. And at the last, we are going to learn the most important thing, which is how to take the components of the vector. First part, let us see the actual difference between vector multiplication and scalar multiplication. So, scalar multiplication, we'll see first. What is a scalar multiplication? A scalar multiplication is nothing but simple algebraic multiplication. Just like how you multiply two numbers, you simply multiply. Here also, just like 2 into 3, 4 into 5, just like this. Okay? So it is what simple algebraic multiplication. And on what quantity you can perform. If you have two or more scalars, you can perform on two or more scalars, or if you have one scalar and one vector, you can multiply these two. Okay. Then what is the significance of it? It is the magnitude of increase or decrease. Okay. It is what magnitude of increase or decrease. What is the meaning of that? Assume you have, yeah, initially, okay, your weight was 50 kg. Okay. Next, after some days, okay, your weight increased to assume 100 kg. Now, what actually happened? You multiplied here with 2, a factor of 2. So basically, you did 50 into 200. So basically, your weight increased, okay, how, with a certain magnitude. So that is the significance of scalar multiplication. So this is actually simple. Next, vector multiplication. What is vector multiplication? It is much more complex as compared to scalar multiplication. Like how vector addition is much complex as compared to algebraic addition. Similarly, vector multiplication is much more complex as compared to scalar multiplication. And vector multiplication can be performed on vectors only. If you have two vectors, only then you can perform vector multiplication. Then, what is the significance of this projection of a vector? Okay, in the later part of the video, you will learn about something called as projection of one vector on the other. Okay, for that, you need the concept of vector multiplication, basically dot product and area of parallelepiped. What is parallelepiped? It is basically nothing but parallelogram. Okay, parallelogram in 3D. So 3D parallelogram is nothing but parallelepiped. Okay, and much more complex shapes. Also, you will find the area using vector multiplication, but it is not there in your syllabus. Okay. First topic, vector dot product. What do you exactly think what a vector dot product is? Let us see. First, let us talk about the basics of dot product. Listen to me very, very carefully. Vector dot product is performed on two vectors only. If you have two vectors, remember this, two vectors only. If you have two vectors, only then you can perform vector dot product. And if you have three vectors, you can't do vector dot product on that. Why is that? I will tell. Now, second part is also very, very important. When you perform the product and the resultant you get is a scalar quantity. When you dot two vectors and the resulting product which you get, it will always be a scalar quantity. This is also very, very important. Now, how is it denoted as? Assume you have a vector A and you have another vector B, and I say A dot B. How do you do? You write A, you write like this, dot and B. and this product will give you a scalar quantity. A and B are not scalars. A and B are what? Vectors. Vector dot product will only be performed on vectors, but the resulting quantity which you get will be a scalar quantity. Is this clear? Now, we'll deal with some formulas. Okay, how to perform dot product. Assume we have a vector A as x1 I cap, y1 j cap, z1 k cap, and vector B is x2 I cap, y2 j cap, z2 k cap. And if you, what do you want? A dot B. A dot B is nothing but x1, x2 plus y1, y2 plus z1, z2. Basically, what you're doing, these two you're multiplying, two a caps you're multiplying and these two coefficient of two j caps you're multiplying, coefficient of two k caps also you're multiplying, and we'll add these two, and the resulting quantity, as you can see, you will get a number. Okay, one formula, a dot b can be written as magnitude of a magnitude of b into cos of angle between them. Clear? Remember this formula. Now let us talk about some basic properties of vector dot product. Okay. First, vector A dot vector B is equal to vector B dot vector A. This is clear. Next, you can also write it like vector A dot vector B plus vector C is equal to A dot B plus A dot C. Okay. Next, if you have some scalar lambda and you are doing lambda times A dot B, this you can write it as lambda A dot B, which is also equal to A dot lambda B. Okay. And if you do it like vector A, if you dot up vector with itself, then you get magnitude of that vector the whole square. Okay. And if you have two perpendicular vectors, let us say A and B, assume they are perpendicular, then the dot product is 0. If A and B are perpendicular vectors, okay? A vector and B vector are perpendiculars. Is this clear? Vector cross product. Next part. This is also very, very important. Now, let us talk about the basics of vector cross product. This vector cross product is performed only on vectors. Okay, that you know. The second point is very, very important. The resulting product is a vector. In scalar, when vector dot product, you are getting the resulting product as a scalar, but here you are getting the resulting product as a vector. Now, how is it denoted? A cross B like this. Okay, A cross B, and you get some vector, assume C. Okay, this is how you denote it. Okay, formula. Before going to the formula of vector cross product, you need to learn about something called determinant of a 3 by 3 matrix. Okay, assume you have like x1, x2, x3, y1, y2, y3, z1, z2, z3. The determinant of this, first you will take this x1, okay, then forget about these two rows temporarily, multiply these two, which is y2 z3 minus multiply these two y3 z2. Okay. Now what you will do? This is plus minus plus. So you will write minus x2. So you will forget about these two rows. Now what? Y1 z3 diagonal y1 z3 minus y3 z1. Next, this is plus x3. Forget about these two rows. It is y1 z2 minus y2 z1. This will give you the value of the determinant of a 3 by 3 matrix. Is this clear? Tell me. Remember this method or formula. Next. Okay, we learned determinant formula. Now, how do we calculate the cross product of two vectors? Let us see. First, in the first row, you will write I cap, you will write j cap, you will write k cap. Now, assume you have a vector A, which is x1 I cap, y1 j cap, z1 k cap. B vector you have x2 I cap, y2 j cap, z2 k cap. And now you have to find the cross product of these two vectors. So write the coefficients of I cap, j cap and k cap here. So which is x1, y1, z1. Remember it is what? A cross B. First coefficients of I cap, j cap and k cap of A vector. You have to write it first. Then what you'll write? Then you'll write B vector, which is x2, y2 and z2. Now evaluate the determinant. Then you will get the answer of cross product. Okay. You have one more formula. Magnitude of A cross B is equal to mod of A vector B into sine of angle between them. Remember, this is mod of A cross B, which is magnitude of A cross B. Okay, A cross B, you will get a vector, and the magnitude of that vector is equal to this. Okay, properties. What? Let us talk about some properties. Firstly, you have to understand that A cross B is not equal to B cross A. Okay, it is not the same, but instead, what is the relation? A cross B is nothing but negative of B cross A. Okay, clear? Now, assume you have some scalar lambda and you're multiplying it like this. This you can write it as lambda A cross B. So you can write it as A cross lambda. Assume you have A cross B plus C. How can you write this? You can write it as A cross B plus A cross C. These are all general properties. Now, very important. A vector crossed with itself is 0. Okay, clear? That's it. Next, what else is left in vector cross product? Direction. Okay, you are getting what a vector as the answer, but what direction is the vector present? Is it in this direction, in this direction, what direction? How will you know? That you are going to learn now. Okay, first assume you have a vector E. and another vector b. And what you have to do, you have to find out a cross b. How do you perform this? First, in this direction, you have to perform a cross b. Okay, one second. I'll clear. Yeah. Now, to find out the direction of the final vector, first keep the tip of these fingers facing in this direction. Okay. Next, is it done? Do it now. Yeah. Keep the tip of your fingers facing in this direction. Now, curl your fingers, four of your fingers in the direction of B. Curl four of your fingers in the direction of B. Now, which direction is your thumb present? Tell me, which direction is your thumb present? Yes, upwards. And this is the value of A cross B. This is the direction of A cross B. Clear? If you don't understand, again I'll tell you. Keep the tip of your fingers facing in this direction. Now curl your fingers in the direction of B towards the direction of vector B, and the direction of your thumb will give you the direction of A cross B vector. Clear? Next, projection of a vector. Okay, so this is not very important in physics. Okay, but still I will give you the formula. Projection of A on B is given by A dot B by magnitude of B. A on B, so B will come in denominator. Okay, A on B, so B will come in denominator, and this is the formula for projection of A on B. Clear? So this is one of the applications of dot product. Next, this is a very, very important topic, that is how to take the components of a vector, and this topic will be used throughout uh, 2 years of your physics. So, how do you take components of a vector? Let us see. Assume you have a vector in this direction A. Okay. Now, it makes some angle theta. So, what usually we do in vector resolution is you get two components. One is vertical component and another is horizontal component. And we say that this is A cos theta. What is A? A is magnitude of vector A. Okay. This is A cos theta and this is A sin theta. Now, how did we get this? I will show it to you. I'll do a small derivation. Now, what I will do, I will form a triangle. I'll complete this triangle. This is, assume this is O. Assume this is A. Assume this is B. Assume this is C. Okay. Now, first, write sin theta. Sin theta is nothing but what? In this triangle. O in triangle OAB. Sin theta is what? AB by magnitude of A. Okay. I will do one thing. If you're getting confused, this is vector A. I will write its magnitude. The length of that vector is A. Now, correct? Now, AB is nothing but A sin theta. Now, if this is a sin theta because you are constructing a square. Don't you think this will also be a sin theta? Yes. Now take cos theta. What is cos theta? Yes, OA upon A. OA is nothing but A cos theta. So, don't you think what I have written is correct? Yes, and every time you can't sit and derive all of these things. So, you should better remember all these results. Okay, next. Next topic, what we have angle between two vectors. Now, assume you have two vectors and you want to find out what angle they make with each other. Is it possible? Yes, of course, it's possible. How do you find out the angle between the two vectors? Let us see. Assume you have one vector A and another vector B. Assume you have one vector A and you have another vector B making an angle theta with each other. The angle between them, how do you find out? Let us derive that formula. First, what is the value of A dot B? We know that magnitude of vector A, magnitude of vector B into cos of angle between them. Now, theta, this is what you want. So, what I will do, I will write cos theta is nothing but A dot B divided by magnitude of vector A by magnitude of vector B. And if you want theta, we will write it as cos inverse A B. So this is the formula for angle between them. And in case you don't know what cos inverse of something means, I will explain it to you very quickly. Assume you have some cos inverse of 1 by. This means that at what angle, the value of cos will be 1 by 2. That is what? 60 degrees. When is cos theta 1 by 2? At 60 degrees. Cos 60 is what? 1 by 2. This is what? Okay. So we'll solve some questions based on dot and cross product. So pause the video and give it a quick try. If you're not able to solve, I will solve it now. Okay. So first, we'll read the first question, which is 3i cap, 4j cap, and 5k cap. And another vector you have is 2i cap and 7k cap. You want to dot these two. First, always write it. Sorry. First, always write the two vectors. 3i cap, 4j cap, 5k cap. You have 2i cap, 0j cap, 7k cap. Now, dot these two vectors. How do you do? Coefficient of I cap you multiply, which is 3 times 2, plus coefficient of j cap you multiply, which is 4 into 0. Okay, this is into, plus coefficient of k cap you multiply, which is 5 into 7. So which is nothing but 6 plus 0 plus 35, which is 41. I hope all of you understood how to find the dot product of the vectors. Okay, quickly try the second question now. Done? Yeah. Now again, write the vectors. 4i cap, 2j cap, 3k cap. Second, 7i cap plus 5j cap plus 8k cap plus 2k cap. What you can write it as 10k cap. Yes, you can add those two same coefficients. Now, Find the dot product between them, which is what? 4 into 7 plus 2 into 5 plus 3 into 10, which is what? 28 plus 10 plus 30, which is 68. Clear? Isn't it simple to find a dot product of two vectors? So we will go to the next, that is find the vector cross product of the following. Listen to me very, very carefully. This will be confusing at starting. So listen to me. So first write a determinant. First, what we'll do, we'll find a vector cross product. Nothing else we'll do first. Write it down. I cap, j cap, k cap. So first, this is A and this is B. What are they saying? They are telling do A cross B. Okay. So which is what? Find the coefficient of I cap first, which is 2. Right? Write the coefficient of j cap, which is 3. Write the coefficient of k cap, which is 1. No, second one. Write the coefficient of I cap, 1. Write the coefficient of j cap, 0. J cap. Then what is the coefficient of k cap? 2. Now evaluate the determinant. How do you do it? First, what did I tell? A cap. This one will deal with first. Hide these two line rows, which is 3 into 2, correct? Minus these two multiply 0 into 1. Yeah, correct. Shall we go to the second row now? Second. This is what? Plus, minus, plus, which is minus j cap into. Hide these two rows and this one row and column. This is what? 2 into 2 minus 1 into 1. Okay, clear? Second row, is it clear? Tell me. We'll go to the next now. Hide these two rows. Write it as plus k cap into multiply these two, 2 into 0 minus 3 into 1. Okay. Now just evaluate it. What are you going to get? I cap times 3 into 2, which is 6, minus j cap times 4 minus 1, which is 3, plus k cap times 2 minus 3. So the final vector which you are going to get is 6 I cap minus 3 j cap minus 3 k cap. So this is the value of A cross B. If you have understood, it's well and good. If you are not understood, it's completely normal. Again, watch how I solve this question. Then you will understand it. Okay? Clear? Again, you solve it on your own, you'll understand. Done? No, this is the vector which we have got. I'll erase the rest. So find the resultant of this vector. Okay? Find out the resultant, which is nothing but what? Tell me the formula. All of you should remember. Coefficient of I cap square, coefficient of j cap square, coefficient of k cap square, 36 plus 9 plus 9, and this is nothing but what? Root of 54. Okay. This is the value of the magnitude of resultant. This is the magnitude of resultant. What are asking? Magnitude. Now you have to find the direction of this vector with respect to another vector. With respect to this vector, you have to find the direction. What is that formula? Cos theta is nothing but A dot B by magnitude of B. So basically nothing but this if you take this as, let us say, C, this will become, and if you take this as A cross B, if you take it as D, basically we have to do small changes. This is nothing but C dot D by magnitude of C, magnitude of D. Basically, you have got one vector which is what, A cross B, and there is some other random vector which is D. You want to find the angle between them. So basically, this vector and this vector you will dot, and you will divide it by the product of their magnitudes. Clear? Now, do the dot product. This is what, nothing but C dot D is what, 6 into 3. Okay, write this vector. Another vector is 3 I cap, 6 j cap, 2 k cap. Now dot, which is nothing but what? Multiply the coefficients of I cap, 6 into 3 plus 6 into minus 3 plus 2 into minus 3 whole divided by magnitude of C. What is the magnitude of that? Magnitude of that is nothing but what? Coefficient of y cap square, coefficient of j cap square, coefficient of k cap square. This you are going to get it as root of 49, which is 7. So, which is nothing but this is 7 and this is root of 54. Okay, root of 54, you can write it as 3 root 6. Okay, 3 root 6. You can write it as minus 6 divided by cos theta minus 6 by 3 into 7 root 6. So 2 times. So theta is nothing but cos inverse minus 2 divided by 7 root 6. This is the answer. Is this crystal clear? Tell me. Understood? Did you understand? Basically, first we found out the cross product of two vectors using the determinant method which I taught you. Okay. If you have not understood that method, as of now, just by heart that formula which I gave. Okay. Next, what we did, we found out the resultant, the magnitude of the resultant by using the formula which I taught you in two classes before. Okay. And then what we did, we found out the direction, the angle between a cross b vector and the another vector which they have given here, which is 3i cap plus 6j cap plus 2k cap, by using the recently learned formula. Okay, so this is how we use dot and cross product in physics. Okay, clear? Components of a vector. We'll solve some questions now. This should be very, very simple. This is what? This is 60 degrees. Split it into horizontal and vertical components. So we'll get it, one will get horizontal component, one will get vertical component like this. So this is 10 cos 60 degrees, and this is 10 sine 60 degrees. So this is nothing but what? 10 times 1 divided by 2, which is 5. And this is 10 times root 3 divided by 2, which is what? 5 root 3. Is this clear? Tell me. Understood? This is a simple problem, just a basic formula. Now, resultant of the force. Now, as soon as you see this question, you may feel what is this? But these type of problems are very, very important. This is 37 degrees and this is 30 degrees. Okay. First, we will resolve this vector. Okay. One by one we'll resolve and we'll write. How do you do? Whenever you get a vector, write it horizontal component and a vertical component. This is 37 degrees. So this is what? 5 cos 37. This is what? 5 sin 37, which is nothing but what? 5 into cos of 37 degrees is what? I told you to remember the value of sin 37, cos 37 and tan 37 in the first class. It's 4 divided by 5, which is 4. And this is nothing but 5 into 3 divided by 5, which is 3. So basically, what are you getting here? This is 4 units. This is 5 units. Okay, that is the first part. So what you can write it as? I can erase, or better write. I can write there is one component of vector which is 5 units, and there is another component of vector 4 units here. So what can I do with this vector? Forget about this. This is 3 units, no? Not 5. This is 3. So I can forget about this vector. Let us talk about second vector, which is in this direction. Write the horizontal and vertical components. This is what? 30 degrees. Okay. Now, this is what? 4 units. The magnitude is 4 units. So this is 4 cos 30, which is 4 times cos 30 root 3 by, correct? 4 times root 3 by 2, which is 2 root 3. And this is 4 times sin 30, which is 4 times 1 divided by 2, which is 2. So basically I can write this as this is in this direction, 2 root 3, and this vector is in this direction at what? Magnitude 2. And what about this vector? Forget about this. Forget about this vector. Now, here what do you have? You have 8 plus 2 plus 3. Why am I adding all of them? Because all of these vectors are in upward direction. And since those two vectors are in same direction, you can perform simple algebraic addition. You remember I taught you this. Here you have 21 plus 4. And here you have 2 root 3, which is in opposite direction. So we will write minus 2 root 3. So this is what? This is 13 units, and this is 25 minus 2, 3 units. Is this clear? Tell me. Okay, so this you will get one vector in this direction, another vector in this direction. So if you want to find the final resultant vector, okay, which is in this direction, what you will do? Root of 13 square minus that something. That is what? Root of 13 square plus 25 minus 2 root 3 whole square. So this will give you magnitude of this blue vector. Now, important thing is this angle is theta. Now, what angle does this make with the horizontal? How will write? Yes, correct, correct. Tan theta is nothing but this value is 13, this divided by 25 minus 2 root 3. If you are not understanding this I'm drawing one triangle like this. But if you're not understanding, what I'm doing is I'm drawing a perpendicular like this, whose size is same as 13. This is a square. So this is 13 units. This is 25 minus 2 root 3 units. And this tan theta is opposite by adjacent. So tan theta, you'll get it. You'll get it in this. So yes, this crystal clear. Tell me. So these type of questions which are solved multiple forces they'll give, and they'll ask find the resultant of this force. You will come across in physics many times in 2 years. Okay, so many times will come across. So it's better you practice more and more such problems. Clear? Tell me. Now, with this, I conclude this chapter as well as I conclude this vector series. Okay, so in vector series, I have covered every single topic which is required for physics, and also some one or two little topics which you might come across in physics rarely, but still in some advanced problems you can come across. But I have covered all the topics, and if you have any doubt and if you want like any derivation of a certain topic in vectors, let me know in the comments down below. I will come up with a video for that also. So with this, I conclude this series. The next series which I'm going to be starting is PYQ series, which is previous year questions of JEE, NEET, and some miscellaneous exams also. So with this, I conclude this video. If you have any doubts, let me know in the comments down below. Thank you. Bye bye.